Hi guys, this is Miss Katz, and today I'm going to be doing the Unit 4 End of Unit Study Guide. I'm going to do one side at a time in different videos so it's easier for you to find the problems that you need the help with. So we're going to just jump right in, and we're going to start with the first thing. List out the characteristics of a direct variation graph. Where does it start? What does it look like? A direct variation graph starts at the origin. And the origin is a special point on a coordinate plane at 0, 0. And it is always a straight line. Because it is a constant rate of change, it makes a straight line. You know, every time you go over 1, you go up 10, so it would keep going in that pattern, and that would create that straight line that you're looking for. Solving the equations below. This one I want you to pay very close attention to because we're struggling with this still in class. And if this were a 5 in the front of this equation, nobody would be having trouble with it. For some reason, as soon as I put a fraction in there, everybody freaks out. But what is really happening to x here? X is being multiplied by 1/5. Well, how do I undo multiplication? I divide by 1/5. So 42 divided by 1/5, whoops, is the same as 42 over 1, because that's how we make it into a fraction. And then we keep, we change, and we flip over the other. And when you multiply 42 times 5, you'll see we get 210. X equals 210. Now the check is when we take 1/5 of, that's times 210, it should equal 42. Well, let's take that 210 and divide it by the 5, because that's really what happens when you multiply those guys. And you're going to get 42. So since 42 is what I get on that side and 42 is what I get on that side, I know I'm correct. Remember that every equation that you solve in on your test, you can use a check to make sure that you got it right. You should be able to walk out knowing you got these correct. All right, question number 3 is an addition equation. So how do I undo the addition that's going on here? And by the way, if this bothers you because we're used to seeing the variable in the front, the commutative property allows us to rewrite this equation to look like this. And if that makes it a little more simple for you to understand what to do, then go for it. Okay, and when we do this, remember we have to regroup here. And so C will equal 116. We can check that by saying 67 plus 116 equals 183. It is not simply enough to put 183 equals 183. We actually have to do the math. The whole point of the check is to do the work to make sure that you actually get the same answer on both sides, that your answer is correct. All right, in this particular equation, it's a subtraction equation. Oops, sorry. How do you undo subtraction? We add. So we're going to add 5.6 to both sides. And notice every time I've done that, whatever I've done on one side, whatever inverse operation I've used, I used it also on the other side because we're trying to balance that equation out. All right, and once we do that, you're going to find that this is 12 and this is 10.2, and that's what J equals. And again, to check it, we're going to go over here, and where J is, we're going to put in 10.2. It should equal 4.6, and I always say should equal because it only will equal 4.6 if, in fact, I did everything correct. That's the whole point of the check. And when we check, we have to borrow. This becomes a 9, and this becomes a 12. And we do, in fact, get 4.6 on both sides, or 4 6/10. So we know the answer is correct. All right, question number 4 says that Jennifer, that might be me, spent $8.99 on a bag of Jolly Ranchers that cost X dollars a piece. If there were 110 Jolly Ranchers in the bag, we need to write an equation that could be solved using inverse operations to find out how much each Jolly Rancher would cost. Notice it says you do not need to solve the equation. Okay? So in this case, $8.99, the cost of the total bag, divided by the cost per, or the cost that's X, per Jolly Rancher, should give me the 110 Jolly Ranchers. You could also write an equation that says 110 Jolly Ranchers times their value, which is times X, equals the $8.99. Either of these are acceptable, and there are probably others as well. All right, write a situation that could describe the inequality graph. Well, we know that this graph represents x being greater than 2. Doesn't equal 2 because if it did, this would be shaded in. So any expression, there are more than 2 students wearing blue. That would be a situation that could describe that inequality. All right, write an inequality to represent the fact that there are at least 13 questions on your test. At least means there could be 13, but that's the lowest number it could be. So our value of x is going to be greater than or equal to 13. Write an equation to represent that there are more than 125 cars in the parking lot. That means x has to be greater than 125. If it's more than 125, it can't be equal to 125. It's only the numbers that are greater than that. All right, in question number 8, it says Gabriel wants to solve the equation 3/4 m equals 25. Which step should he do first to isolate on one side of the equation, to isolate that variable? So what's happening to m? It's being multiplied by 3/4, so you would divide by 3/4. All right, in question number 9, it says Judy spent $5.67 on oranges that cost 63 cents each. If x is the number of oranges, write an equation that would determine how many oranges Judy purchased. Notice it doesn't ask for you to get the final solution. It's just asking you to write the equation. So it says we could do a couple things. The amount of cost per orange times the number of oranges will equal how much we spent. Or how much we spent, trying to think if I want to use that one. How much we spent divided by the number of oranges will equal how much each cost. All right, in question number 10, write a direct variation equation to represent the data in the table. We're looking for what's happening from here to here. So each time you're multiplying by 5. Once you figure that out, that's your constant of variation. So k here equals 5. The standard equation for a direct variation equation is y equals kx. So the equation for this one is going to be 5x. That will get me every pair of numbers that will satisfy this equation. Okay? Write one possible solution and one non-solution to the inequality x is greater than 4. So one possible solution, so here's the solutions. Anything that's greater than 4. So 5, 100, etc. Non-solutions are 4, because it doesn't say equal to, or anything that's less than 4. So any number there. That is going to vary by whatever you put. Explain how to solve an equation. This one is one of those things you guys hate to say, but all we're going to do is we are going to solve an equation, you're going to use inverse operations on both sides of an equation to isolate the variable. Ultimately, our goal is to figure out what the value of the variable is. Once we isolate it, get it by itself, and then we know that we have found its value. Okay? Number 13 says complete the table to satisfy the equation y equals 12x. Well, basically, if they give us the x, okay, it's y will equal 12 times that x. Well, in this first case, it's 12 times 1, which is 12. In the second case, y will equal 12 times 2. So that's going to be 24. In the third case, it's 48 equals 12 times what? And to solve that, we would divide by 12 on both sides. So x would equal 4. And then the final one, y equals 12 times 5. Well, that would be 60. What inequality is graphed on the number line? All right, well, it's going to be, what I would recommend you do is you put the x and the 2. Those are the two things we're comparing here. And we know it's including the 2 because we've got a solid dot, so we know we're going to have an equal sign. The question is, if the alligator is always going to have his mouth open towards the biggest numbers, these represent our x, and this is our endpoint. Is the alligator going to want to eat the x's or the endpoint? It's going to want to eat the x's because they are the biggest numbers. And that's how you set it up. So in question number 15, we're going to do the same thing. We've got x and 4. In this case, we are not putting an equal to sign because the circle here is open. That means it doesn't include the number 4. It'll include anything less than number 4. So which one is the alligator going to want to eat? Well, the biggest number in our set is 4, so it will choose to eat the bigger number. All right, guys, hang tight, and you will have the answers to the back side.